Hello everyone, welcome to another Year 10 Chemistry revision video. Today we're going to be going through the 2018 Triple Chemistry Unit 1 paper, and it's a higher tier paper. Question number 1, here we're going to be looking at the hardness of water practical which contains soap. Just a bit of a difference view here is that rather than adding the drops using a pipette, we're going to use something called a burette for this, which is a very precise way of measuring a volume. Just to make note down at the bottom then, so I've got water sample A required a small amount of soap before and after boiling. So that means A is soft water. B requires a large amount of soap before boiling, and this stays exactly the same, which means it's permanent hard water. C goes from being very hard to soft, which makes it temporary hard water. And then 15 has been softened slightly by boiling, but it's not completely soft, so it's going to be a mixture of permanent and temporary hard water. And we're going to use these results on the next page in the questions. State which sample only contains temporary hardness and explain your answer. It's C, and it's all hardness is removed by boiling. Give one similarity in the composition of temporary and permanent hard water is that they both contain calcium and magnesium. Remember composition, what they're made of. Discuss the benefits and drawbacks of living in a hard water area. Well, the benefits, you have stronger teeth, stronger bones, and it prevents heart disease. The drawbacks is that it causes limescale and forms scum with soap instead of a lather. We've then got a solubility curves here. What you're going to probably need to do is keep rewinding back and forth if you'd like to hear me talk through these, but just for the questions, we're going to have to find the amount formed with some potassium nitrate, KNO3, when it cools from 100 to 20. And there's going to be a large amount of water of this, so we're going to have to do some sort of multiplication after, but I go up from 100 and across to 240, and I go up from 20 to 28, and I'm going to use these numbers on the next page. I've also marked up here the intersection between two, which is where they've got the same solubility, so we'll use these answers on the next page. So that first one was the solubility where they're exactly the same. That was where those lines are crossed, and I went down to 51. The next one here was it was 200 grams of water, so remember I went up and across from 100 to find 240, up and across from 20 to find 28. I take them away, and that gives me 212 per 100 grams. It's 200 grams, so I'm going to double it to 424. Suggest why a student may be surprised at the temperature range on the solubility curve. If you look back, it goes above 100, which is really, really strange. Give the symbols of the ions of the group 1 elements present in the compounds shown on the grid. What we've got there is the group 1 ones are the sodium and potassium. So I go to the back and I find that sodium is Na+ and potassium is K+. Explain how these ions are formed from their atoms. Well, they're both in group 1, so they like to lose one electron to get a full outer shell. And I've got here my balancing for you guys. I've given you my workings. I noticed that I had an issue where I had 1 nitrogen on the left and 3 on the right. So what I did is I put a 3 in front of each of those to balance that, and then the rest of the numbers then matched after I recounted. The boundary between the Nazca and South American plates is a destructive plate boundary. Describe what happens at a destructive boundary. Two plates of different density move towards each other and collide. The denser plate melts into the mantle, leading to earthquakes. We could have also put volcanoes there. Draw a cross on the diagram to show a constructive plate boundary. Describe what happens. Well, look, I've got a cross there where my lightsaber is, where the arrows are going in opposite directions. And it's that two plates move apart and magma rises through the gap. New rock forms as the magma cools. And your last one here was state one effect of plates sliding past each other was earthquakes. Use the equation to work out the formula of sodium thiosulfate. Now what we need to do here is if we draw a line down the middle, the question mark plus the HCl will add up to all of the elements on that side. So, for example, we'll draw a line in the middle. I can see I have got 2 H's at the moment and 2 Cl's. On the other side, I've got 2 NAs. I've also got 2 Cl's, so they match. I've got 2 sulfurs. I've got 2 plus 1, which gives me 3 oxygens, and I've got 2 H's. So at the moment, only the H's match. So I can see left over is 2 sodiums, 2 sulfurs, and 3 oxygens, and I've put that into a chemical formula there, and that will go in the question mark box. The symbol AQ in brackets in an equation tells us our substances are aqueous. What is meant by this? That tells us they are dissolved in water. Use information from the equation to explain why the cross disappears. Well, look in the equation. We need to be looking for a reason why this has changed colour. And if we look here, the reason it has changed colour is because we formed some solid sulphur. Now remember, when you form a solid from 2 liquids, we call that a precipitate. So it's there, a solid sulphur precipitate forms, which blocks the view of the cross. Another student said that one of the mean values was incorrect. Identify the incorrect mean and give your reasoning. If you're ever asked about an incorrect mean, everybody, you need to be looking for an anomaly. I can see that my anomaly is 29 because it doesn't fit in with 21 or 23. So that means the incorrect mean is 24.3. So I put that there. And I've given the reasoning is that they included an anomaly in the calculation and 29 should have been excluded from further calculations. State what conclusion can be drawn about the effect of temperature on the rate of this reaction. Explain your conclusion using particle theory. Well, as it gets hotter, the mean time gets shorter. So if the time is getting shorter, that means it's getting faster. So what I'm looking for, the higher the temperature, the faster the reaction. This is because particles move faster, meaning more successful collisions occur. Write letters A, B, and C on the diagram in the positions of the elements that fit the following descriptions. Well, I've got an electronic structure there for A with 3 electrons. That means it's lithium. So I look at my periodic table and A goes there. B is the element in group 2, period 4. Well, remember, groups go along the top. So I know that B has got to go in the second column. And periods, guys, remember we count from the top right, not from the left-hand side. So period 4 is there, so B goes there. And an element that shows both metallic and non-metallic properties. Well, we've got to remember that there is that staircase that runs, that separates metals and non-metals. You could have put C in any position which is next to that staircase. Now, the following table shows the atomic numbers and boiling points of the inert gases. You've got them there. They're asking you to plot the data on there and draw a suitable line. This would be something now that you'd have to perhaps go and check your points with your teacher just to make sure you've got them in the correct spot. But remember, just key points here. The line of best bit's got to be a curve that is one smooth curve. It doesn't have to be perfectly. There can be wobbles, remember, guys, but we don't want any shading. Describe the trend in the boiling point shown on the graph. Well, I know that the atomic number is increasing there and the boiling point's increasing. So I've written that boiling point increases as atomic number increases. The following table shows the boiling points of the inert gases in both degrees centigrade and Kelvin. Now, these are just different ways of measuring temperature, like you can measure distance in miles or kilometres. What we want to do here is we use the information in the table to calculate the boiling point of argon in K. What I've noticed from the table is that the difference between each of them is you've got to add 273. So I do minus 186, add 273, and that equals 87. Give one use of argon, explain in terms of electronic structure why it is used for this purpose. It uses an inert atmosphere for welding, and it's because it has a full outer shell, it is unreactive. This is a triple only question. Now, so if you're not doing triple, you can sort of look towards the next question. Limestone is an important raw material. It can be used as a building material or converted into quicklime and slate lime. Describe and explain the sequence of reactions carried out in the lab to convert limestone into slate lime. So first thing, calcium carbonate, which is limestone, to quicklime, calcium oxide. We're going to heat the limestone strongly. The carbonate will glow orange. There's the equation. For quicklime to slate lime, we're going to add a small amount of water to the quicklime once it is cooled. This reaction releases heat as it is exothermic. Water is converted to steam due to the heat, so fizzing is seen. And we go from calcium oxide quicklime plus water gives me calcium hydroxide or slate lime. My slate lime will also crumble. Group 7 elements are known as the halogens. The following table shows the observations made when the first three members of the group react with oxygen. We got there. So fluorine explodes in cold and dark. Chlorine explodes in sunlight, and bromine is a small explosion with a flame. So we should be spotting that the reactivity decreases. Use your knowledge of the electronic structure to explain why all of the halogens react in a similar way and why they react more slowly on going down the group. Well, first thing we got to remember, we got 3 marks here, remember? So all of 7 electrons in their outer shell, and I know that because they are in group 7. So they're going to gain 1 electron. The reactivity decreases down the group because the outer shell becomes further from the nucleus, making it more difficult to attract an electron. Hydrogen fluoride is highly corrosive and can be used to etch glass, which is mainly silicon dioxide. Balance the symbol equation for the reaction between hydrogen fluoride and silicon. 4 and 2. Come and see me if you need some help with this. And our last one here was calcium fluoride reacts with sulfuric acid, H2SO4, to produce calcium sulfate and hydrogen fluoride. Give the symbol equation for the reaction. I've worked out all of these with top swap drop by looking at the back. They gave me sulfuric acid, and then I've added a 2 there to balance the F's, because look, I had 2 F's there and only 1 there. A sample of antimonium chloride of mass 26.7 was found to contain 5.45 grams of aluminium. Calculate the simplest formula of this chloride of aluminium. So just a reminder, the word simplest, we could also use empirical. And what we need to remember here is that of the 26.7 grams of aluminium chloride, 5.45 grams of it of aluminium, which means the rest of it is chlorine, and I've worked that out by taking them away. So we end up with a mass of 21.25 for chlorine. I divide each of those masses by their mass number from the periodic table, and I get a number of 0.201 and 0.598. Remember, I circle and divide by the smallest one, and that gives me an answer of 1 and an answer of 3. So I get Al1, Cl3. Sodium is extracted from sodium chloride. The overall reaction is shown in the equation below. 2 NaCl's give 2Na plus Cl2. When carrying out the reaction, 120 kilograms of sodium chloride, now I know the mass, so I'm going to put a little K up there, was found to produce 38.05 grams of sodium. Calculate the maximum possible mass of sodium. So even though they've given us that, that isn't the maximum possible that could be produced, and use the figure to calculate the percentage yield. So first of all, there's my reacting mass equation. Unknown mass equals no mass over known MR times unknown MR. I've calculated the MRs. Remember with this is the one where we include the big numbers in front. So my MR of 2NaCl is 117, and my MR of 2Na is 46. So I'm going to do 120, which is my mass, no mass, divided by my known MR, which is 117, times 46, which is my unknown MR, and that gives me 47.2. I then do the percentage yield. So what did I actually make? Divided by what did I theory should have made, times 100. So I do 38.05 divided by 47.2 times 100, which gives me 80.6. Suggest a reason why the yield is less than 100. We're always going to put here incomplete reaction. And suggest why this must be carried out under dry conditions. Well, guys, we're using sodium, and sodium will react with any water or moisture. A triple only question here, guys, triple only. Calculate the relative atomic mass of lithium and give your answer to 3 significant figures. So we've got the isotope 1's mass is 6, times by the abundance 7.59. Isotope 2's mass is 7, times the abundance, which is 92.41, divided by 100, which is 6.92. State the difference between the atomic structures of lithium-6 and lithium-7. Lithium-7 has 4 neutrons, and I know that because that's what it looks like on the periodic table. So I take those numbers away from each other. And lithium-6 has got 3 neutrons. Describe the trends in the stabilities of the group 2 carbonates and nitrates. Well, if we look at them, both the stability of the carbonates and the nitrates increases because those numbers are getting bigger. But look, nitrates, the increase is greater. So nitrates are more stable. That's my second mark. And for carbonates, the range is much smaller, only from 117 to 267, as opposed to 89 to 700. When a carbonate decomposes, it produces carbon dioxide gas. Describe an experiment that could be used to show that the carbon dioxide gas is produced during the reaction. So we're going to heat the powder and bubble the gas through lime water. The lime water will turn cloudy if carbon dioxide is present. When calcium nitrate decomposes, it forms calcium oxide, oxygen and nitrogen dioxide, NO2. Write a symbol equation. Again, I've gone to the back with top, swap and drop to work out those two. I've remembered that oxygen is a diatomic. It hates being lonely, so it's O2. And nitrogen dioxide is NO2. We've then, for our final question, got a literacy question. So I'm going to give you the answers for these here. I can't flick back and forth, sorry, so you can pause the video for your answers for this one. There's your answer to the tick. Here's the answers to that last page. Come and see me if you've got any problems or any questions you'd like me to go through in a bit more detail.